Here's the Earth. Here's a big old tall tower. Big old wires holding it up, and here's you. You're not that big. If you were, you wouldn't even be able to stand up. Okay? But climbing the tower, right? Okay? Now, the information you're given is that weight is inversely proportional to the square of distance from the center. As you get further and further from the center of the Earth, your weight decreases. Now, if you climb a mountain, you won't notice the difference, although if you had good scales, you could maybe measure it. Okay? But not more than a few grams. Okay? Between the depths of the deepest part of the sea and the height of the highest mountain. Okay? And maybe some, yeah, maybe a few tens of grams. So weight equals K over R squared, where weight is your weight and R is your distance from the center of the Earth. Okay? Well, now it's very easy to figure out what you would weigh if you climb a certain distance above the surface of the Earth. Okay? Now, of course, your distance above the surface is not your distance from the center, right? How far is it from the center of the Earth to here? Anybody ever been to the center of the Earth? Well, that'd be pretty inconvenient. It's really hot, and lots of pressure. You wouldn't get very far. Okay? So you wouldn't know from direct experience, but I'm astounded that even my engineering students didn't know what the radius of the Earth was. I'm not sure what they're asking you to know in these schools, in this curriculum. Not knocking the schools, but the curriculum is awful in some ways. In some ways it's not too bad. Anybody know what the radius of the Earth is? How big is the thing? You say you want to go somewhere. What's the maximum distance you would have to go?
I think the diameter is less than 100,000 kilometers.
100,000 kilometers. Nah, it's not that big.
That's a little bit less.
Okay, you're off. You're off by a factor of about 8. Okay.
A decent quantity.
Not quite 8, closer to 7, between 7 and 8. Anyhow, if it was that big, it'd be a lot harder to walk around on the surface because gravity would be a lot stronger. Okay? So, thanks. Not a bad start. You know, Moon is about 400,000 kilometers away. Okay? It's about a quarter of the radius of the Earth. So, you can get a little perspective if you think about that. Okay, so diameter of the Earth, we'll just do miles. About 6,370 kilometers, but we'll say 400, and that depends on where you measure it. But 4,000 is easier to remember than 6,370 or 6,350 or whatever it is, because it varies from one point, you know, from pole to equator. Okay, so, and even there are variations within that, but anyhow, okay, it's 4,000 miles, right? And I don't know, how much do you want to weigh?
I'm like 195.
Huh?
I'm like 195.
195. So, if R equals 4,000 miles, Mark is 195 kilograms.
Let's go with that.
Yeah, that'd be 450 pounds or something like that, 430 something. Okay, so at this distance, weight is 195 pounds, right? This is Mark climbing the tower. And we don't really want you to do that because it gets really hard to breathe after you get a little ways because there's no air. Okay? Or negligible air. Okay. So, whoops. 195 pounds equals K over the square of 14,000 miles, right? 4,000 miles, not 14,000. You square it and you get 16 million. So 16 million times 195. Yeah, I don't have room to finish it here, so just follow me up to here. Now 145 times 16 is pretty close to 2,500. So I think you're going to have about 2,500,000. That's a little high, it's a little lower than that. Pounds times miles squared. So for any distance, 2,500,000. That's 2,500,000. Wait a minute now. Yeah. I need 3 more zeros. Well, it's going to be messy, but I got to do it. Okay, so there is 500,000. Another zero. I'll put commas in there. Okay, pounds times miles squared divided by r squared. Now this should be a familiar process to you. We did a lot of it for over a span of about a week back sometime in March. Okay? And what we're doing right now is kind of reviewing so you can pull things together and giving you some high points that you really understand. So, now let's just say that we resolve the air problem. Maybe this tower has air in it. You just got to go up the steps. So how much does Mark weigh when he's 1,000 miles above the surface of the earth? You climb that far, couldn't you?
Okay, sounds good.
Oh, absolutely.
Yeah. And hopefully there's food, you know. And hopefully you don't have to keep coming back down to get the food so you go back up again. Okay, so what's the weight at the 1,000-mile height? Well, at the 1,000-mile height, R is 5,000 miles, isn't it? We'll see if I got all the zeros right here. You'll be down to 100 pounds. So if you want to lose weight, just climb that tower. Okay? Now I can check that out by proportionality. Seems a little low. 4/5 squared is 16/25. So I must have done something wrong somewhere, because it'd be a little more than that, maybe around 120 pounds. So there's probably something wrong with my arithmetic, but you can correct that. You understand the process? First of all, you got to know what proportionality means. You got to know what inverse proportionality means. Your variable's on the bottom, right? And inverse square proportionality means it's 1 over r squared. This is nothing but a vertical stretch of the basic reciprocal function. Okay? And this is a lot easier than this because you don't have to get 2 simultaneous equations. You basically got one equation that you got to solve for one parameter, and then you get your rule, your formula, and then you can use it to find W if you know R, or if you want to find R, if you know W, you could find R. Where would he be if he was down to 100 pounds? Well, according to my numbers, he'd be there, but I probably did something a little bit wrong in the multiplication or something. Okay? Make sense? Hopefully. The process is you take your data, you plug it into the right form, and you get a model. You just got to know what the form is. Okay? Sometimes I'll tell you, sometimes I'll just say it's a quadratic function and you got these data. Okay? Or it's a pendulum and you got this data. I'll probably tell you what a pendulum is. It's basically inversely proportional to the square root, which we established a long time ago. Okay?